Hi guys, this is Dr. G here, and in this video we are going to talk about reduction of alkynes. And before starting the reduction of alkynes using hydrogen, I would like to mention about the reduction of alkenes video that I have posted earlier. So you might want to go back and revisit that video of reduction of alkenes, because it will be helpful in understanding the reduction of alkynes. Okay, all right, so the reduction of alkynes is very similar to the reduction of alkenes. Okay, so you can easily achieve the reduction of alkynes by using hydrogen, of course, using hydrogen in the presence of a metal catalyst. So if you remember the previous alkene lessons, we typically used metals like nickel excuse me, platinum and palladium in order to reduce alkenes. So you can use that type of metals such as nickel, platinum and palladium in order to reduce alkenes into alkynes, reduce alkynes into alkenes or alkanes. So this reduction of alkynes is two steps. The reduction of alkynes is two steps. Of course, in the first step you will reduce the alkyne into an alkene, and in the second step you will reduce the alkene into an alkane. But here is the thing, just because this happens in two steps doesn't mean that you can always control it. Okay, you can always stop after the first step. No, that is not going to happen. Okay, if you want to stop at the alkene, you might have to use specific type of catalysts or reagents. Okay, so normally if you just use hydrogen over a metal catalyst like palladium or platinum, the alkyne will fully reduce into alkanes. Okay, it will basically go from alkynes to alkanes. But in the next slide I am going to show you a reaction which we can use to reduce alkynes into alkenes. So you can say that this is controlled reduction. So the reduction that involves Lindlar catalyst basically reduce alkynes into alkenes. Okay, and the other important thing about this reaction is that the Lindlar catalyst based reduction will basically convert your alkyne into a cis alkene. Okay, it will convert your alkyne into a cis alkene. So let's say you have a 4-carbon alkyne like this. Okay, so if you use Lindlar catalyst, which is basically a platinum and calcium carbonate based catalyst. Okay, so if you use hydrogen in the presence of Lindlar catalyst, okay, your alkyne will be converted to a cis alkene. Okay, it will be converted to a cis and alkene. So it will not go directly to your alkane. Okay, it will not go directly to your alkane. Okay, so it will only give you a cis product. It will only give you a cis product. And let's say you want a trans alkene from an alkyne. So if you want to generate a trans alkyne, what you do is you use sodium or lithium as a metal catalyst, and then you reduce in the presence of liquid ammonia. Okay, so you will reduce your alkyne in the presence of a metal like sodium or lithium and liquid ammonia, and this reduction will basically give you a trans product. Okay, so we just learned two different reactions. So if you want to generate a cis alkene, you will use Lindlar catalyst. But if you want to use, or if you want to get a trans product, you will use lithium or sodium and liquid ammonia, and it will give you a trans compound. Okay, so that is how you conduct a reduction in a controlled manner. Okay, but of course, if you further treat these cis or trans alkenes with hydrogen and let's say a metal catalyst like platinum or palladium, they will go to alkanes. Okay, so in here I have given you the mechanism, so you can pause the video and take a look at it. But honestly, for our discussion, the mechanism is not that important. Okay. All right. So let's see if you could do this one. Okay. So let's see if you could do this worked example. So you will pause the video and try this now. But in a second, I will give you the answer. All right. So in here, what we have to prepare is a trans product or trans alkene. Okay, we want to generate a trans alkene. So if you want to have a trans alkene, you can start with an alkyne. Okay, you can start with an alkyne, and then you can treat the alkyne with liquid ammonia and a metal like lithium or sodium, right? So in here, what you need is 2-octane, okay, 2-octane, and you will treat it with liquid ammonia in the presence of a metal like lithium or sodium, and it will give you the trans alkene. It will give you the trans alkene. Okay, it will give you the trans alkene. All right. So in the next video, I'm going to talk about oxidative cleavage of alkynes. Okay. But if you have any questions from the reduction of alkynes, just let me know. Okay, you guys have a good one.